Well, good morning and welcome to another fabulous Mars Lab video conference. My name is Craig.
And I'm Isabel.
And boy, do we have a good one for you today. We have on the line, and we'll be speaking with him very shortly, Dr. Chris McKay. And also coming into the studio a little bit later on, a young lady by the name of Tara Jokic, who is from the University of New South Wales, and she'll be sharing with us a little bit about herself and also her studies that are related to the kinds of things that Dr. McKay is doing as well. So we have 3 schools logged in so far. So let's three. We have 3.
Yes, we have
so let's
3.
just meet some of our schools before we meet our special guests. So here we go. So can everyone hear us loud and clearly?
Yeah.
Yep. Yes. Excellent.
Yeah. Excellent. All right, so let's say hello first of all to Javal. Javal, where are you guys?
Hi, Javal.
Hi, Javal. We can actually see ourselves there, Javal.
Javal, it'd be great if we could see the students, because right now what we're seeing is the screen of us, and we'd rather see those lovely faces in the classroom.
Oh, that's
Hello.
better. All right. Hi, Javal. All right, and how about Tumbarumba? So Javal's up in Armidale, and Tumbarumba, you're down southern New South Wales. So give us a wave, Tumbarumba. There we go. Excellent. And just down, this is the Armidale School, is that right? Yes, the Armidale School.
Hi, guys.
All right, looks like everybody's online in Armidale today.
Yes, that's right. And I think we're expecting two more schools, so during the conference they might pop in, and we'll say hi to them when they do. So.
All righty.
Excellent. Well, it's lovely to meet you all today.
We might get them to mute.
So what we might get you to do is mute your microphones. So with your remote control, just press on mute so that we don't get all the background noise. And when it's time to ask a question, we'll get you to turn those microphones back on. But lovely to meet you all today. But I know we are all dying to meet our special guest, Dr. Chris McKay from NASA's Ames Research Center in California. Chris is a field geologist, and he's been doing a lot of work on finding out about the origins of life. And he studied extremophiles, and he's got a special interest in terraforming, which is changing the environment on a planet to make it more like Earth, so that Earth life can live on it. So that's a really interesting topic, and we'll be talking to Chris about that today. Chris also works on, he's worked on many NASA missions, but right now he's working on the Curiosity mission right now, and he works on the ChemCam and SAM instruments. So if you know your Curiosity rover a little bit, you'll know those instruments. But so please join me in welcoming Dr. Chris McKay today. Hi, Chris.
Hello, everybody. Good to talk to you.
Thank you so much for joining us today. It's really great to be able to talk to such an expert as yourself. What's the weather like in California today? It looks like it's nice and sunny in your office.
It is. This is still summer here. We're getting toward the end of summer. Schools are just starting. The school across the street from my house started today. But it's still summer, and it's still a typical California summer. This year we're having a severe drought. Our rain and snow is 1/5 of normal, but that makes for good weather. But everything's good.
Probably makes for good astrobiology too, does it?
Does. It makes, if you're interested in dry, how life survives under dry conditions, we might be finding out about that here in California. You guys know all about it in Australia too, of course.
Yeah, yes, we do.
Yes, we do. So tell me what you're up to this week, or what you did last week. What's going on at Ames Research Center right now?
Well, this morning, my focus was on Mars, in particular on some results that are coming back from the Curiosity mission. Curious results of Curiosity. I'm not supposed to be telling the world about this, but I will anyway. We're seeing what look like whiffs of methane and changes in oxygen. So we're on a planet where we're expecting things to be pretty steady, oxygen and methane to be pretty steady, but they're not. They're moving, they're varying. And so last night I was thinking, well, what could be causing that? So this morning I spent the day sending off an email to a colleague suggesting a possibility. So a lot of my time is spent working with the data from these missions on Mars, trying to figure out what's going on. The neat thing about it is that it's always a surprise. It never turns out the way we think it will. I guess that must be some law of the universe. Things never turn out the way you think they will. And that applies on Mars, apparently. And so it's always something surprising. And I love that. That makes it exciting. In fact, if things turned out the way I thought they would, it'd be pretty dull. No surprises.
That's right. So that's what makes science exciting, isn't it? Always surprises.
Exactly. Always learning something.
So, Chris, can you tell me, is that a kind of a typical day for you? What does Ames, what actually goes on at the Ames Research Centre? I mean, we hear it mentioned, and NASA seems to have so many institutions. So what's the background for the Ames Research Centre for all our listeners today?
Ames started off focusing on airplanes. It was built before World War II, focused on airplanes. As NASA has done less and less airplane work, Ames has done more and more space stuff. Well, I'm part of the space group. One of Ames's principal areas of focus is what we call astrobiology. And that's the connection between biology and space. And that's what I'm interested in. That's why I'm at Ames, and that's why I'm at NASA. The connection between life and space. And that connection, as we heard earlier, is both the search for life and also the possibility of life going out into space. Biology looks at both of those. Is there life out there? Could we send life out there?
Yeah. Wow. Well, we know that your job has taken you. I mean, your focus is on Mars and finding life on Mars, but you have done a lot of research here on Earth, and your job has taken you to a lot of really interesting and amazing places here on Earth. I know that you've been to the Atacama Desert. I think we have a photo that's going to come up. But the Atacama Desert, you've been to Death Valley, you've been to Antarctica. So those are some pretty extreme environments here on Earth. What have you found there, and what does that tell us about life and about what life needs and where it can be found?
What we've done to prepare for searching for life on Mars is go to places on Earth that are like Mars. And the fundamental property about Mars that's important biologically is how dry it is. So I've gone to the driest places I can find. And in fact, when I was in Australia the first time, I went to the driest place in Australia, which is near Maury. That's the area of Australia that's the driest. It's always the driest place I'm interested in because dry is a problem for life. And what we found is that life on Earth, at least, really needs liquid water. That is the edge of survival. What I hoped, or maybe what one could hope, is that we would find an organism that had figured out how to grow without water, how to do something else, but not on Earth. It isn't there. We tend to think of life as everywhere. And that's true on Earth because water is there. Take away the water, the liquid water, and we don't have any life form that can survive. And so that's the challenge on Mars, is the absence of liquid water. And so indeed, searching for dryness, I've gone to the Atacama, Australia, Sahara Desert, the Antarctic dry valleys, all these profoundly dry locations, and look for what kind of organisms can survive under these dry conditions.
So where's the water in? Where's the water that the life can survive in something like Death Valley, or in Antarctica? I mean, I don't mean that to sound like an obvious question. I'm just keen to see where you actually find the water and where the organisms are in something like one of those extreme deserts.
Well, let me answer that by talking about the examples that we found of how organisms get their water in a clever way. In many deserts, and you can see this in the dry parts of Australia, photosynthetic organisms live underneath quartz stones. So the quartz stones are translucent. Light comes through them. They trap moisture. So if you go into dry deserts and find white stones and pick them up, underneath the white stone, there's a layer of green. And this is in virtually every desert in the world. And in Australia, near Mari, in that area, you can find these, in the driest part of Australia, these so-called hypolithic algae. For a long time, we thought that they were the champions in living in dry conditions. Then, a few years ago in the Atacama, we discovered an organism that's even more clever in its ability to get water in a dry place. And these are organisms that live inside salt. In a desert that's very dry, salt can become like a rock. It doesn't dissolve. There's not enough water to dissolve it. And the organisms live just inside the salt. And salt can absorb water from the air at high relative humidity. And that's the water that these organisms use. So those organisms in the Atacama, the only place we found them, in the driest part of the Atacama, represent what I would call the champions on Earth for learning how to photosynthesize in dry conditions. So if we were to send one organism from Earth to try to live on Mars right now, that would be the organism I would nominate. So that's what we found.
It sounds like you'd also like to lift up a rock on Mars as well and have a look underneath.
Exactly. If we saw a white rock on Mars, picking it up and looking underneath would be irresistible. And in fact, I do this all the time. When I go to deserts and I'm walking by the Mojave, the Atacama, Australia, I see a white rock, I've got to pick it up and look underneath it. It's a reflex reaction almost.
Actually, we have quite a few white rocks in Australia that are just painted and sitting at the fronts of driveways. It's been an old tradition to paint big pebbles for some reason. I don't think they're quite the same. They actually tend to kill the stuff underneath those ones in that particular case. Alrighty, so thank you very much, Chris. What we're going to do is I'll just get you to keenly listen now, because we're going to introduce a nice studio guest for ourselves today as well, who has an interest in the same kinds of things that you do. So welcome Tara Jokic. Tara is from the University of New South, is working at the University of New South Wales, or studying at the University of New South Wales as well, is a master's student, and she's at probably our most favourite part of the University of New South Wales, which is the Australian Centre for Astrobiology. Mm-hmm. And I recently met Tara, so welcome and thank you for coming in. I recently met Tara at the Earth Sciences Conference, the Australian Earth Sciences Conference, and we got talking, and she had this great poster up talking about her work, and I thought, we're talking with Dr. Chris McKay, I should bring Tara in, she should meet Dr. McKay, and also I want her to share a little bit about herself with all of our other scientists out there today in their classrooms to get an idea of, you know, to think about the path that you might like to follow in science as well. So, Tara, thank you.
Hey, nice to meet you all. So basically, I'm a geologist and a paleontologist, and so I look at rocks and fossils. And in fact, I'm looking at some fossils called stromatolites in Western Australia, and they're 3.5 billion years old, right? So basically, why my work is really related to astrobiology is because one of the ideas behind looking for life elsewhere is also looking at ancient life on Earth to understand what we would look for elsewhere, like on Mars. And so stromatolites, if you don't know what they are basically these rock structures that are built by microorganisms. So communities of microorganisms build these rock structures. And I find these out in these 3.5 billion year old rocks. And so that's basically what I'm mapping at the moment.
Actually, we've got a couple of pictures that you brought in. We'll see if we can bring those up just as you're talking. So can you just tell us where this is?
Yeah, so this is in Western Australia, in the Pilbara. And so the rocks that you're looking at are 3.5 billion years old, as I mentioned. And it is beautiful out there. Right now it's quite a desolate country that's just covered in pretty much one type of grass, which is called spinifex, and it's quite spiky because it's very dry out there. But, you know, once upon a time, these rocks were not what they look like today. They were They were a dynamic system that had a lot of different life living in it in the form of these microorganisms, which is what early life on Earth is and was. So yeah, I mean, it's really interesting work for me, and I can take it and hopefully transcend it into looking for life elsewhere other than Earth.
Can we see one of the stromatolites here?
Yeah, so
are you watching this too, Chris?
Yes, I am.
Yeah, I bet this is up your alley, is that right?
Well, we'd certainly love to find something like this on Mars, wouldn't we, Tara?
That's right. So tell us what these are, Tara.
Yeah, so basically these are one of the newest findings that we've actually got from the Pilbara. And these are some elongate, sort of irregular looking stromatolites from top view. But in a side view, they're domical and conical. And so stromatolites come in a lot of different morphologies, and these ones in particular are likely to be living in shallow water environments, and they're phototactic, so that means that they're basically growing in a fashion to get energy from the sun. So what you just saw there, actually nobody else has seen. This hasn't been documented, this hasn't been published. And those are actually probably some of the oldest convincing evidence of life on Earth as we know it. So, yeah, I'm really happy to share it with you.
So
well, you guys are lucky today because you're getting news from Curiosity that no
we're not
one's heard
supposed
yet.
to hear. That's right.
Now you're seeing these images.
Yeah.
Oh, wow.
Fantastic. Actually, Tara, you got a bit of a question yourself then for and then we'll actually switch to some student questions because I can see them all thinking ready to ask their questions. But I thought you might have one for him.
Okay, just a quick question, Chris. So a few friends of mine were discussing this actually yesterday, and if we were to find life on Mars and we found, you know, a diversity of it, and we started classifying it, how would we actually do that? Would we have like a species name with maybe an M at the end of it? Or would we just kind of integrate it into the system that we already have?
Well, that's a good question, and I hope we have that problem someday. It may be that we find life on Mars, and it maps onto our own tree of life. It may be that Earth and Mars share a common origin, and life is exchanged between the two planets via meteorites. In which case, we would map it on our tree of life, and it would follow the same taxonomic classifications as life on Earth. On the other hand, and the much more interesting scenario, life on Mars is not related to life on Earth. It represents a second genesis. Then we have to invent a whole new classification system. Then I don't even know how we would do that. I'd leave that to the taxonomists, but we'd have to do something. We'd have to have a new designation for Mars life, but we'd also have to add the designation to Earth life to indicate that it's Earth. It's sort of like the .au at the end of a internet, so dot whatever. We sort of have to start putting .earth for Earth life and .mars for Mars life. That would be wonderful.
That's fantastic. Instead of the World Wide Web, we'd have the Universal Wide Web.
Look, we have a question, Chris, from Cameron at Duval High School. Cameron, are you ready with your question?
Yeah, thanks. My question was actually the same of Tara's, actually. Is just pretty much about the same. Sorry?
So just ask it, though.
Just ask it, because I think it is a little different.
What would you do if we found life on Mars?
So did you hear that, Chris?
Yeah, I did.
Yeah.
I can answer that. This is a very good question. And it's a question that, in fact, surprisingly, we don't spend much time discussing at NASA. We spend a lot of time on how to search for life on Mars, but very little talking about what do we do when we find it. Sometimes I say, like the dog chasing a car. He doesn't really think about what is he going to do when he catches the car, right? And we risk being in that same position. And it goes back to the discussion Tara and I just had. If we find life on Mars and it's related to us, it shares a common origin with life on Earth, and I don't think it really poses many problems or issues. But if we find on Mars that there's a different type of life, .Mars, not .Earth, then I think it poses a lot of important issues about quarantine, about bringing it to Earth, about putting Earth life on Mars, and so on. And the whole question of changing Mars to make it more habitable. Now we have to make it more habitable for the life that's there, not for life from Earth. So indeed, what we find will have profound implications for what we decide we do.
Yeah, actually, and just nicely related to that, from the Tumbarumba School, from Tumbarumba, Jake, you had a question too, which you'll probably see is nicely related. So could you ask yours, Jake, please, of Dr. McKay?
Yep. If life was found on another planet, how would people manage the specimen?
Sorry, it was a question, how would we manage the specimen?
Yeah, so if life was found on another planet, let's say e.g. Mars, how would we manage the specimen?
Okay, good question, Jake. In fact, there are international rules for how we will deal with things like that, particularly if we want to bring it back to Earth. Because, in fact, even if we think there might be life in the sample, if we want to bring it back to Earth, it has to be carefully controlled. Any sample brought back to Earth from Mars will be treated with strict quarantine and containment. These are rules set by international treaty. And so we have to take a very careful approach because we don't know what would happen if something was alive and got released accidentally into Earth's biosphere. Now, on Mars, if we had humans on Mars and they found something and it was alive, I think they would take the same cautious approach. Even if you don't think it's harmful, you never know. And once there's an infection or once there's a release, it's sometimes very hard to undo that. As you guys know, with the story of rabbits, which is the story, Rabbits in Australia is the story I always use when I talk about dangers of contamination, biological contamination. And here it's the most appropriate use of it, talking to you guys since you know it directly. So one wants to be very careful, and international law and international treaty insists that we do so.
Following that, Calum at Tumbarumba also has a question.
Okay. Yep. Okay. What ethical conundrums would hold us back if we did discover life?
The ethical conundrums. I think the ethical issues are important. And as we talked about earlier, they rest on the nature of the life we find. If we find life on Mars and it is related to us, then there's, I think, minimal ethical issues. They're like bacteria on Earth. They're related to us. But if we find on Mars organisms that really represent a second genesis of life 2.0, different type of life, different DNA, different structures, then I think we have to think hard about what we do with that from an ethical point of view. And when you talk to scientists about it, you often get three reactions. One is, well, put it in a jar and stick it in the laboratory. Otherwise, don't worry about it. The other is, okay, quarantine Mars, leave it alone, don't do anything. Just back off and don't touch. My approach is the third one, which is go help. We're from the government, we're here to help, and go in and see what those guys want, see what kind of life they're living. They're obviously not doing very well on Mars, and help them, encourage them, add whatever ingredient they need that they're missing to allow them to become a planet-dominant species like life on Earth is. So indeed, the ethical issues are very important when we find life on Mars, if it's a second genesis.
Actually, and I definitely want to come back to some of those controversial issues down the track. But I can't miss the opportunity to go to Selena at Tumbarumba. Selena, can you ask, I know we're back on Tumbarumba again, but it lines up perfectly with what Chris has just been talking about. So could you ask yours, please, Selena?
Is finding life of a second genesis more important than finding life in general?
Well, I think it is. I think if we find life on Mars, and it is a second genesis.
Chris, could I just interrupt? Could you just explain what you mean by the second genesis? Because obviously Selena's been studying that, but what do we mean? What's the difference between first genesis and second genesis?
Right. If we look at life on Earth, we see common biochemistry and genetic history to all life on Earth. There's only one life form on Earth. We think it traces back to a common ancestor. And in fact, the kind of structures that Tara is studying date back to that common ancestor. So we assume, but we can't prove it, we assume that the life forms that made the structures that Tara is studying 3.5 billion years ago are our ancestors. So they are genetically connected to us. We assume, we know it's true for life on Earth now, and we assume that it's been true in the past. And all life on Earth, present now and present back to 3.5 billion years ago, is a single genetic system of related organisms of common shared descent. So let's call that life 1.0. Now, when we go to Mars, we might find organisms that are also related to us. They are part of life 1.0. But we might go and find organisms with such a different chemistry, such a different DNA, that they can't possibly be related to us, just in the same way that a book in Chinese is not related to books in English. You can have a library full of English books. You have one book in Chinese, and you can tell that it is language 2.0. It's not language 1 anymore. That's what I mean by a second genesis, a life form that is different enough that we know it's not related to us, and it must represent an independent, separate origin of life. Now, I think that's profound for two reasons. One is it would tell us that right here in our solar system, life started twice. And if that's true, that means the galaxy is full of life. It started twice here in our solar system. It started billions of times all over the place. The second reason it's important is we would now have another type of life to study and compare. And we might learn a lot about life as a phenomenon by having more than one example to study. The limitation, one of the frustrations of astrobiology is that we only have one data point, one example of life. So that's why I think finding a second genesis on Mars is vastly more interesting, both scientifically and philosophically and ethically, than finding life as we know it, life related to us, or finding no life at all.
So, so if we did find this second genesis of life, you were saying earlier that we would help it and make Mars an environment that it could thrive in. How would we go about doing that? How would we go about terraforming Mars?
Well, okay, let me first say, Isabella, that that's my personal view. It's not NASA official policy. But my view is when you see life forms in trouble, you should help them. And so the first assumption there is that you can tell that it's in trouble. And my argument for why I think life on Mars, if it's there, is in trouble, is that if it wasn't in trouble, it'd be covering the whole planet like it is on Earth. The second assumption is that you know how to help it. That we're not sure of. So we'd have to first study the life that we find there and see what is it like. Does it like liquid water? If so, that could account for why it's in trouble. And we would alter Mars to give it more liquid water. Maybe it likes something else. And so the goal would be to help Mars become a planet rich in life. How we would do that would first search out that life, figure out what it's like and what it needs, and then decide what to do next.
Right. So you're saying if you see something in trouble, give it a helping hand. But I know that some people are of the opinion, and I have to admit that I am of this opinion right now. My mind can be changed, but I'm the opinion that the universe has, not that it has a do not touch sign on it, but that maybe we should leave it the way it is, and that it doesn't mean that if we can do something that we should. What do you say to the people with that opinion?
Well, this is an important question, and it's a question of values and ethics. It's not a question of science. Science could tell us how to help if we want to help, or if help is needed, but it can't tell us should we help. And I think intuitively, we appreciate that life is a value. And so if we go to Mars and find life there, and we find that it's struggling, we are going to all have an instinctive urge to help it. I think even you will, Isabella, will have that urge, whether you admit it or not. We discover life, and the scientific report comes back and says life is there and it's hanging on by its proverbial microbial fingernails. We could say, well, we'll just stand by and watch as it dies out. I don't think we will. I think we'll say, quick, let's finally do something that's ecologically positive, and let's go help.
Yeah, I know Isabel much better than you, and no, she might say leave it to itself.
I wouldn't mind. So how does that account for us here on Earth then? If we're, we do see the effects of global warming, but we don't seem to be really doing anything about that. So. Oh. Yeah. So and in fact, would the idea of terraforming Mars give people the illusion that there is a safe haven once the global warming effects here on Earth occur?
Yeah, there's two important points there, Tara. One is the notion that we can use Mars as a backup plan, a plan B for Earth. And I think that's ridiculous. It's absurd. It's absurd ethically, but it's also absurd technically. The notion of a lifeboat or a backup sort of implies that you've got enough spaces in the lifeboat for most of the passengers. Well, there's 6 billion passengers on Earth. Trips to Mars could carry half a dozen. The notion of it as a lifeboat is absurd. Mars, ethically, of course, is absurd too. It'd be ridiculous to think that because you bought a second house, you should trash your first house. We should assume that managing the Earth is an absolute requirement. Giving up on the Earth is not an option. And in fact, I would argue that studying life on another world, studying ecosystems on another world, will be part of how we learn to better manage the Earth. So I think it is morally and technically absurd to think that we can abandon the Earth. But your first point is we do not have a very good environmental record on Earth as a species, and this is certainly correct. But I don't think that should prevent us from doing positive things on Mars. And the story or the analogy I sometimes make is on Earth, we are like a bull in a china shop. Earth is so complicated and so full that just about anything we do, something gets broken. We can't take a step without breaking something. But on Mars, we would be like a bull in a big empty field. There's nothing there. And anything the bull leaves behind could actually be useful in making the field grow. So that's the difference between Earth and Mars. And maybe on Mars, and only on Mars, will humans be able to do something that's ecologically favorable.
All righty. So actually, let's go beyond that a little, and let's assume that we one day are going to Mars. Charlie from the Armidale School, you had a question for Chris.
When will people be able to be going to Mars?
Well, when will people go to Mars? That's a question that's very hard to answer. In principle, we could send people to Mars soon. In reality, I think it's going to be a long time, partly because there really is no reason to rush. We can learn more about Mars through robots. We can answer questions like life and distribution of things like stromatolites. We could even search for stromatolites with rovers and airplanes and so on. So there's no motivation to rush to send humans because it's quite expensive and dangerous. I think it's going to take a long time. So my prediction is there will be at least 40 or 50 years from now before humans go to Mars. I hope I'm pessimistic, but that's what I predict. So if you want to live to see it, Charlie, don't smoke, run every day. Keep it low on the alcohol, and yeah, don't step into the bus.
So, Chris, you were just giving Charlie some advice there in case he wants to go to Mars. I know that the nature of space exploration is quite multi-generational. I know how much time it takes to plan and prepare for a mission. It takes years and years. What does that mean to the young people that are watching today who are in high school and are about 15, 16, 17? How can they be involved in that space exploration?
That's a very good point, and it's a cultural point that one of the reasons I like space exploration. And let me give an example of that. The Cassini mission to Titan and Saturn, I got involved in it just after I got my PhD. And I worked on that mission for 20 years before I got the data. So, and people had been planning that mission for 10 years before I got involved. And so I am working on missions right now, which will not generate data until I'm long gone. And students that are now in middle school will be the scientists that will analyze the data for those missions. And so space exploration of necessity has to recruit generations to follow, because some of our projects take generations to complete. Outer solar system missions in particular. So in fact, I like that because it motivates us to go out and recruit students, talk to students like we're doing now, and get people involved, because those people will be looking at data missions 20 years from now that we're just starting and planning right now.
Yeah, absolutely. And so what should young people be doing right now in high school if that's the kind of thing they're interested in?
Yeah, what kind of things can they experiment with and things like that?
Yeah,
can they... what sort of astrobiology and things, that kind of spacey thing can they do here as well?
Yeah, well, let me give you two answers to that. One is I get a lot of emails from people that basically say, students, I want a job like you. What should I study in school? And I always write them back, take a lot of math. Doing math is like learning to ride a bicycle. You only learn it by practice. It's not something you just are born knowing or that you have a talent for or somebody else doesn't have a talent for. It just comes with practice. Do a lot of math, take a lot of physical science, physics, what I took, chemistry, biology, geology. And I say that's one thing you need to do to get involved. The other answer to the question is you're very lucky living in Australia. It is probably the most Mars-like continent and the most interesting astrobiological continent on Earth. As you saw from Tara's work, the oldest evidence for life on Earth is in Western Australia. Some of the most interesting deserts in the world are in Australia. Interesting dry salt ponds and salt lakes. And if you can only be in one continent on Earth and you're interested in astrobiology, Australia is a good candidate. So without too much travel, as you all know, without too much travel, you can go out into deserts and you can see dry playas, you can see hypoliths, you can see, if you get out to Western Australia and up to the Pilbara, you can see stromatolite. Go to the Dawn of Life Trail. Lots of opportunities to do it.
Actually, let's just come back to Tara. I like living in the marsiest place on the planet. That's terrific. Actually, Tara, how did you get started on your path into science?
My career kind of started a little later, actually. So I finished high school and I always loved science, but I didn't really think that I'd end up getting into it and doing what I'm doing today, I'll be honest. And I spent about 5 years actually after high school sort of just having odd jobs, and I didn't really know what I wanted to do. And then it was like I always had an interest in astronomy, but it just kind of came about that I wanted to do something, something really interesting in my life, and something that, you know, I thought maybe was unrealistic, because I kind of thought going down this path of you know, astrobiology I actually hadn't even heard of until I went to university, but I just thought that going down a path of maybe astronomy was a little bit out of my depth. And I did it anyway. I applied to get into Macquarie University actually and do a Bachelor of Science in Astronomy. And after my first semester I went to New Zealand, and I actually did the Tongariro crossing, which is in the volcanic Taupo zone, which is in the North Island of New Zealand. It's a 17-kilometre hike, and it's beautiful. And it is a desolate land. I mean, we're talking volcanoes on either side of you as you're walking through this hike. And I thought, well, why would I study the planets up in the sky when I could study the planet beneath my feet? And so I changed my degree from being in astronomy into doing geology. And then I found out that I could do paleontology subjects, including, you know, things looking at fossils. So, you know, these were things I was always really interested in, but didn't think that they were a realistic career path. And then eventually that opened me up to astrobiology. So once I heard about astrobiology, I just thought, you know, this is what I'm interested in, like philosophically, as well as an actual tangible, you know, way of approaching it through science. Just really clicked with me. And I did have doubts. I very much had doubts, but I kind of just trusted my gut at the end of the day and thought, you know, I want to do something that I'm interested in. And if I'm interested in it, then I'll probably do well in it. And, you know, I do still have struggles with, you know, certain things in terms of just challenges in science, but that's what makes it so much fun. And so, yeah, that's kind of how I got to where I am today. And I really encourage people to, you know, if you're interested in things, go out and do them. And don't be scared when they become difficult, because they do, but it's worth it, right?
So did you do lots of maths and lots of physics and things?
I didn't do lots of maths, and I didn't
Chris,
do physics, and I didn't do biology in high school. And I did it all, I learned all of it when I went to university. But, you know, I really do wish that I did do them in high school, because it would have made my life a lot easier now. So, you know, if you are interested in these sort of things, like, get into it, you know, make sure you get the fundamental skills now. And you don't have to, you know, you don't have to run into university straight after school, but, like, I mean, I encourage it, but, you know, it's sort of like just, you basically need these fundamental skills if you want to have a career in science. And I wish I had done them, but it doesn't mean that it is the be-all and end-all, you know, and so...
And you don't have to be really, really good at science.
No, you don't have to be. You don't have to be.
To like what you do.
I'm certainly was never a high distinction student. You know, like I'm not gonna. It really doesn't bother me, but I still do very well in what I do, and you know, I really enjoy it. Like unbelievably enjoy it.
And I remember something you said to me at that conference was you thought that there was nothing left to discover.
Right.
Yeah.
Yeah, that's exactly right. So basically, when I was in high school, I suppose the reason I didn't continue doing or didn't do science and didn't think about going into it is, well, one, that I thought was unrealistic, which is not true. And two, I thought that everything had been discovered, and that is so not true. You know, there are so many things out there that we just don't know, and even the things that we do know, we only know like a little bit of that. And so, you know, there is just the world is your oyster. You always hear that, you know, and you don't believe it until you really, the more you learn, the more you realise that.
You don't know.
Exactly. Yeah. That's exactly right.
The world is your stromatolite.
Yeah, pretty much.
Yeah.
Angus, at the Armidale School, you have a question for Chris, don't you?
Yes, he does.
What drove you to go towards this career path, and did you ever have any doubts?
What got me interested in what I do was a series of events, sort of like somewhat accidental. When I was in high school, I was interested in science, but when I got into college, I found a telescope that needed to be repaired in the closet. I like to fix things. I fixed it, started looking to the sky. That got me into astronomy. And then I went to grad school thinking I was going to study some astrophysics or something. And Viking landed on Mars. landed on Mars the year I went to grad school, and the results from Viking came in, and I got very interested in that. Here was a planet, Mars, that had everything needed for life, but didn't seem to have life. And I thought, well, isn't that odd? And I'm still thinking, isn't that odd 30 years later? So it was really the timing. If I had been 2 years later, I probably would not be in astrophysics and not be doing Mars. I might be doing some other field of science. It's what strikes you. And I realized that I'd be happy no matter what I was doing if I was interested and passionate about doing it. And I just ended up in space science and the question of life, and I've very much enjoyed it. It's been very interesting. But there's many other interesting things in science. And one thing I realized, and Tara was mentioning this, there's so much that's not known. That just about anywhere, any field of science, you can zoom in and drill down and find interesting questions that have been yet to be addressed. You can find fascinating topics in many, many different fields. So follow your interest. If you're interested in science, follow your interest and go through whatever doors open, and just be prepared to be surprised and delighted by the kind of things you can find.
Chris, would you go to Mars yourself?
I would go to Mars if they could get the trip down to a couple days instead of months. In 6 months, I'm pretty tall, and flying to Australia to me is the limit of tolerability. So when the engineers tell me it takes 6 months to get to Mars, I tell them, get that down to a couple days, please, and then I'm willing to go. So, but in reality, humans won't go to Mars till long after I'm able to do a trip. So it's still in the distant future.
How do you be so patient? You said before, there's no rush. There's no rush to get there. And I find that when I think about all these kinds of space things and the vastness of the distances and the incredible amounts of time, someone in your position with so many things that you would love to see happen, and yet they're just, millions, thousands of years, ridiculous time frames. How do you cope with that? Or do you have those same kinds of thoughts at times?
Well, I think I personally cope with it in two ways. One is, although my sights are on Mars in the long term, I do a lot of research on Earth. Like Tara, I work on places on Earth, and it's more accessible. I can get results right away, publish papers right away. So I mix the long-term, distant goal with near-term projects that are very immediate. And it's funny, I work with people in Antarctica, and they complain, oh, it's so hard working in Antarctica, you can only get there once a year. I said, boy, I think that is luxurious. I'm used to thinking about Mars where we have a mission once a decade. No one's going to go there for 40 years. So it's a matter of having the right perspective and the mix of perspective. And the other thing, one of the wonderful things about science is you have to appreciate it as a collective effort of humanity. It's not me doing something on my own. It's me contributing a piece to a collective endeavor of humanity. And that helps give you a perspective that makes the long times and the small contributions adding up much more satisfying.
All right, so we've covered a whole array of issues today. But I've been watching the students in their classrooms there and seeing those young minds ticking away. I wonder if we can do a little bit of a show of hands here on a couple of the things that have come up. The first thing, if I can ask you this, after hearing Tara and hearing Chris, who in the classrooms, put your hand up if you would go to Mars?
Put them up
right
way
up, nice
up
and
so
straight.
that we can see.
Just want to see. Only a few. Leave your hand up if it was only one way.
A few hands went down.
Yeah, a few went down. All right, so we're probably, only really half a dozen?
Yeah.
Half a dozen out of our 100-odd students watching at the moment. And the other one then, the one that you brought up before about, because we know that both Isabel and I differ on this a little bit. You know, do you believe that there's a sign on the planets in a way, as Chris sort of referred to it, that says, do not touch? We know Chris's idea. You know, he says, yes, we should get in there and help it. Hands up if you believe that we should help. If we find some life, we should simply help it. We should go and do our very best to help it.
All right.
Okay.
That's quite a few hands.
You are outnumbered.
Chris,
you are outnumbered.
Yeah, I know. I don't know, Chris, if you could see that, but that was quite a few hands.
Yeah. That would be most. The majority.
Yeah, I'd say.
The majority.
Over 50%.
Hands up if you're definitely against. You basically think that humans should stay where they are and maybe just look but don't touch. Up your hand only, Isabel. Isabel, the only person. The only person. All right. Fantastic.
All right, well, I think this brings us to the end of the conference today. Chris, thank you so much for joining us. It's been so interesting and really thought-provoking to have a chat with you. And I'm sure we'll all go home tonight and have a lot of things that we need to kind of digest and think about. But everyone at the schools, thank you very much. Can you all help me give Chris a big thank you? Turn your mics on. I want to hear the thank you.
And Chris, if some of our young people, Chris, wanted to follow up on some of these things, can they, I'm not suggesting that you hand out your email to everybody, but can they follow up through the NASA sites and things, or can they actually make contact with scientists?
Yep. You can email me and I can send them stuff. I'd be happy to send them reprints of all my papers, which some of which discuss these ethical issues and the connection of life on Earth to life on Mars. So, indeed, you can find me quite easily if you just put Chris McKay NASA into any search engine. I will pop up, and on the webpage that NASA has, you can see some of the papers. But if you have a specific question or want a specific paper, send me an email and I'll send you a quick response.
Fantastic.
Excellent.
That is terrific.
Well, thank you very much for taking the time to speak with us. And I guess, well, we have and thank you, Tara.
Yes, we've got to thank Tara. Everybody thank Tara, please. Thank you, Tara. Thank you very much for coming in. After hearing Tara, how many people are going to take science now? All right, some of you there, yes. All right, let's say goodbye. We have a tradition here at the Mars Lab that when we say goodbye at the end of a conference, it's Mars Lab out all together. So Chris, this means you too as well. And so here we go, on 3. On 3. 1, 2, 3. Mars Lab out. Mars Lab out.